afternoon all. I'm John Handscomb from Akerlof. Thanks for joining the session today. We're going to talk about decarbonising precast concrete and the project that we ran with a number of partners, as you can see on the slide there. So ourselves, PC as buildability and design management experts, Forterra in relation to precast manufacturing process, Akerlof, who supported the team in mapping carbon throughout the process, Curtains, who worked on the design, and Construction LCA, who helped us verify our findings in terms of calculations and accuracy. So I'm John Handscomb. I'm a partner of modern methods construction consultancy Akerlof, and we are currently working with Ministry of Justice and gain their support to run decarbonising precast concrete as a project. And that project used the baseline of the new prisons programme, which is looking to build 20,000 new prison places with a focus around rehabilitation and improved sustainability. So net zero is a big driver, along with improved efficiency, both in construction but also in operation. And the benefit of having this as a baseline is that one of these prisons has already been built and handed over. Also going back really that the MOJ have been using a relatively mature precast solution for getting on for 25 years. It's gone through a number of iterations. They're currently on site at Glen Parva, and then there's 4 large developments and a number of house block extensions and replacements going on across the estate. So what that means is, from a carbon point of view, it's really important. They're creating lots of carbon, but equally in terms of the data that is currently held by the teams, but equally by running the project, the influence it can have on the future estate gives it traction and real benefit. And really, what's underpinning all that is the principle of a platform, and so the MOJ's precast solution is effectively a platform, a kit of parts, if you like, which you're probably all starting to hear about or heard about or involved in. And there's a number of people now entering in the market who are using a platform approach to their construction solutions. So picking out people like Collider, which is a spin-off from Wilmot Dixon. On the volumetric housing side, people like Top Hat and volumetric in other areas, people like Red 10 are using the principles of platform constructions, and there's many others to drive their products and solutions. What this allows, really, for me, one of the biggest benefits is that process of continual improvement. And so just to embed those principles of platform, and why it's important to carbon is everything gets defined and works together in various solutions. So equally the same technology for prisons in terms of its construction method is equally applicable to, it's widely used as method in student accommodation and residential buildings. It's just that the finishes might be different, but the construction methodology and principles are regularly used in those settings. So it's interchangeable by build type, if you like, and then by breaking that down into components to parts, so structures, envelope, services, volumetric pods and finishes. That's how a platform relates to construction. And this project concentrated really on the frame solution, some of the embedded MEP and the external wall components to create that envelope and drive efficiency through a structural facade solution, for instance, which takes out you're using the structure of the facade then to use part of your main structure. And so what that gives you is in this project is a precast set of parts, components, if you like, that go together, can be refigured for various sites and various different types. But it also, in doing so, it enables really strong mapping of the supply chain and where decisions are made, where everything comes from, and equally well-defined BIM and digital models that allow calculation around where carbon sits. And we talk about precast, but we talk about pretty what we call intelligent precast. So, for instance, this is a diagram of the floor slab to a cell, and within that floor slab, you've got the heating mats, recess for shower trays. So you don't have a shower tray, you just have it's cast in as a recess, and then the fixing points for light fittings and all those things. So you might think of precast as being sort of hollow core or stairs, and this is quite applicable to those sort of elements, but equally this is precast with a level of intelligence, if you like, in that it's serving more than the one function of a structure. And so that kit of parts, they comes together. They're pretty large units. So on the left there, you'll see the mold for the wall that divides the cells, but equally forms the back of the riser, and then more traditional casting of floor slabs. And what you see there is some images really of so that's the wall that forms the back of the riser. You see all the builder's work is already cast into that, and then the wall panels are fully finished with the windows. So that hopefully gives you a feel for what the baseline project was, the principles behind the platform approach to its methodology, and hopefully now what I'll show you is how we took that and drove out carbon from different angles. So the project itself had four key objectives. The first one, the main one, really was to reduce carbon, to achieve a significant reduction in carbon from the baseline, but to do so in a way that was manufacturable. So I think what we've done is not cutting edge. We've taken effectively existing research that was established and well tested, and we've looked to apply that research. So we're not talking about anything too novel in what we've developed. And what that meant is that it can be manufactured across a number of sites, a number of manufacturers, and that level of technical readiness is high in its nature. It's to maintain that strength. So the properties that concrete has, strong properties around fire safety, noise reduction, structural strength, 120-year design life are maintained, but equally maintaining commercial viability. So ensuring that anything that we looked at and developed was commercially viable in its nature. And so precast follows a relatively linear life. So effectively raw materials, so sands, aggregates, and cements are brought together to a precast factory where they're effectively mixed together and to make precast concrete, and that product is then taken to site, installed, used with a design life, say 120 years. It may last that long, it may not, and then deconstructed, and it goes through hopefully a level of recycling to be reused again in the process. So that is the life of precast, and one of the things that we wanted to understand is in that journey where carbon sat and where the decisions sat that made that carbon, where you could affect decisions to reduce that carbon quantum of load. So we also recognise that that traditionally R&D around improvement and around carbon or cost reduction is quite often done in silos. So you've got a linear process, and material manufacturers will develop their improvements. Designers will look at how they can optimize design, and the same for that testing and manufacturing process and that installation. So one of the things that we're quite conscious of was to break those barriers down, and those barriers aren't often because they're actual physical barriers. It's just because it's a linear process. So sometimes one end of the process doesn't get to have that conversation with the other, or what have you. So and we were looking for opportunities where redundancy in one person's process might be able to be used by someone else to reduce carbon. So looking at everything through the lens of carbon, but breaking down that cycle. So as a group, with our expertise across that life cycle, if you like, looking at it holistically, and where we could use say redundancy within the various processes to improve maybe someone else's. And I think that was both taking it out of the project lifetime, so we weren't dominated by we've got to deliver these prisons. So the project was run as a project rather than a bolt onto to the actual main project, which was led by timeline, and getting everyone in the room where the main focus was that lens of carbon really made a difference. And so in mapping the whole journey, we worked through with all the partners to capture where carbon sat in that process. So using EPDs, using real world data from the prisons that were either been built or already built, and monitoring within the manufacturing process, we're able to build up a full picture of all the carbon, where it sat, and got into huge amount of detail. I think on the day that we started debating the journey length of spacer pegs within the units, I thought we're probably at the right level of detail here in terms of calculation depth. And what that allowed us to do then is to visualize where carbon sat. So over 80% of the carbon is created prior to a precast unit getting to site. Around 5% of that carbon is actually in the precast manufacturing process, and less than 4% of carbon is actually created on site. So whilst moving from, as example, diesel generated cranes to electric, it made a difference, and it's really important. But actually affecting the amount of concrete and how it was made up had a far greater effect on where carbon could be reduced and the volume of carbon which could be reduced. So really understanding which elements had the biggest influence, and thus which areas to target. That process really supported our ability to do that. And the other way we looked at carbon was by mapping through the BIM models. So we took the BIM models and mapped carbon by component. And what that led us to is maybe what people already know, I don't know, but is effectively within the structure, floor slabs dominated where carbon sat. So we might have more columns, we might have more stair units, but in reality, the volumes of both concrete and rebar within the floor slabs had the biggest contributor to carbon. And so our starting point then was to spend as much time as possible in what we would call the heavy polluting units, to see what we could do to reduce carbon in those areas, because they would have the biggest effect on the outcome. And so this graph here just breaks down each precast unit type and the volume of carbon in each one of those elements by both concrete and rebar. And so what that then allows us to do is start to make data-enabled decisions. So taking that existing data set, model it through in terms of using the BIM models to heat map where carbon sat within the building, visualize that in graphical terms, and then work a way to reduce those so that it could be applied then to the next round of prisons. And that's what's that's what's happening. So our research has been taken, and the MOJ with the Contractors Alliance are now applying the findings to reduce carbon in the next round of the estate. And again, that comes back to the platform, because we could have done all this research on a historic project that wasn't going to get rebuilt, and then it has less value. And really, if you look at thinking about carbon within the floor slab, and this would relate to both precast and in situ and other forms of construction. Actually, the easiest way to reduce carbon is to reduce the volume of concrete which you're using, and also the volume of reinforcement in which you're using. So we interrogated the loads, so the load criteria from the base specification, and established that some of those load areas were quite historic and have been in the standards for a number of years. But the way that a rehabilitative prison was being designed was actually meant that some of those loads were overstated. And so by interrogating those loads and then rewriting the standards, which the MOJ have done, was one of our bigger wins in reducing carbon and establishing that optimized design life. So we looked at reducing from 120 years to 60, but we found that actually the longer duration was whilst increased carbon slightly, not by enough to change that design life, which allowed for the option to reconfigure, repurpose. The optimization of component size, so making sure that components were sized effectively to have that best balance of unit geometry, unit thickness, its reinforcement content, and its concrete content, and looking at using voids and those sort of things to reduce that content. Looking at mixed strength, so the balance between mixed strength and reinforcement requirement, optimizing the mixed strength against the reinforcement. And sometimes, because of the manufacturing process of precast, actually using a stronger mix which had more cement in it meant we could have a thinner unit with less rebar. So playing around with those levers, if you like, to make the optimum use of strength was really important. And then talking about voiding, and then recognizing the impact of builders work and inconsistent builders work. So if you're looking at stacking of units and clear lines of structure, as soon as you start to take away those clear lines of structure and effectively apply sort of cantilever loads, if you like, that increases the rebar content and can affect the volume of carbon within each of the units. So the project went through that process of optimization to get better efficiency. And one of the other things we recognize in that collaborative process is that, and this is quite a big issue, but can be used as an opportunity, in that designers were designing a minimum strength, so somewhere in that sort of C40 minimum strength requirement. Because of the casting process, the requirement to have a 16-hour striking time for the precast unit, so that you could cast one every day, we're actually achieving strengths of 65, 70, 75 newtons, so much higher strength than design. But what happens there is really that never gets used back into the design calculation. So designer says, oh, they're overachieving the strengths I need, tick that box. But actually what we did, we took that step backwards and said, okay, well, if this is a requirement of the process, how do we reduce the cement content to minimize carbon through that? But equally, if we are going to achieve these strengths, because that's part of the manufacturing process, how do we use the stronger strengths in the concrete to affect other decisions? So actually recognizing that we're going to achieve C65 or C70, that allowed us to then reduce the unit thickness and the reinforcement content. So and the reason we could have extended the casting period and gone out to a 2-day period, but then that really affects the commerciality of the process. And one of the things we want to do is make what we were doing relevant and applicable. One of the other areas that we saw opportunity and strengthening our specifications, so really ensuring that specifications were well written and really clear about the sourcing of materials, and in particular reinforcement. So by nature, to be honest, precast manufacturers tend to source aggregate locally, because that's think of economics, and often precast factories are in locations of good aggregate source and the likes. But actually reinforcement was one of the areas where people assume that reinforcement is going to be sourced within the UK. It's going to be high in recycled content. But actually that's, if you look at the data of the inflows of reinforcement from around the world, China and a number of other places, actually we import a lot of reinforcement, and the carbon content between the different EPDs was quite alarming in my view, and actually specifying high reinforcement content, preferably from a local source, makes a really big difference to having surety around carbon. So just assuming that all reinforcement is the same and all cement manufacturers are the same is not a great starting place. So I think one of the messages I'd like people to take away really is actually really consider about where you're sourcing material from, and often travel distance isn't the definer of low carbon. It's more to do with manufacturing process, in the case of reinforcement, recycled content, that makes a difference. And so once we'd optimized the design, sorted out our material sourcing and making sure that was the best it could possibly be, we then undertook a number of trials, so making sure that what we were suggesting, the design mixes that we'd come up with, and we also looked at the concrete mix, was manufacturable, so not lab manufacturable, but manufacturable in a factory. Funny that was really important to us. So we ran a number of trials, various sensors in different forms, so walls, columns, floor plates, slabs, to make sure that we had something that was workable. And again, we didn't do anything groundbreaking really. We didn't use sem-free, so we looked at sem-free and those sort of types of products, but they didn't fit with the manufacturing process. So more of a PFA type blended mix, but with a lot more sort of stabilizers and accelerators, chemical based, to increase that curing time, and so we were able to then reduce carbon by about 20% within the mix. Well, one of the areas that we started to look at but didn't take forward fully into our research was the use of sensors, and if we're taking it further forward, then it's quite fascinating really around. So we've got long-term data capture, so we catch that information within the curing process, but actually one of the things that will allow you to reduce your cement content is tracking weather data. So by combining casting data and weather data to reduce cement content on warmer days and only increase cement content on cooler days, sounds really simple, but it doesn't tend to happen. There's not too much dynamics going on in precast factories around cement content other than winter to summer. Then actually this would allow, and this does allow, more finite use of the right amount of cement within the mix, and reducing that cement content has a massive impact on the carbon total. And so really, without doing anything particularly spectacular, but just doing the basics well and taking relevant research and applying it, we're able to reduce carbon content by 40%. I think the biggest takeaway from me within all this is actually, whilst we wait and hope for world-changing technology to come forward, if we just took this approach to every project, we can make a big difference now. And I think it's quite daunting to think that we've got to get to net zero and we've got to drive a huge amount of change, which does need to happen. But equally, just by looking at where materials are sourced, floor loadings, are we using the most optimum mix? Have we got the correlation between design load and manufacturing load? We can make really big impacts tomorrow or today. So that's one of the messages I'd like everyone to take away. And so what we achieved that 40% reduction against the IEC database and 29% reduction against the ISTRUCT database, which also highlights as within the industry standard databases, there's some variance around aggregated carbon data, which people should be aware of and hopefully acknowledge and consider how that affects your project or program. We achieved that manufacturing and the ability so we could deploy, and this has been deployed now, maintain that strength. And what we did was commercially viable by taking out a significant concrete volume that also allowed effectively a more expensive mix, concrete mix, because we've got less volume, but you can afford a better mix basically. So we're very pleased that we achieved our outputs. Any questions?
Thanks, John. There's a few questions in the Q&A box, so I can either read those out to you, or if you can see them, you could kind of pick.
Yeah, I've got them. So I think, yeah, would you be looking to use this more widely, i.e. not just MPP program? Very much so. I think we've published a report, and that process I think can be followed in any construction method really. It doesn't really need to be precast even, it could be an in situ frame. So I think, yeah, it's definitely a process that could be followed in more than one sectors and precast. Mike, do you look into cement replacement opportunities to reduce carbon? We did, so we increased the PFA and those contents, and we're about 50% in terms of that. So, but that's in situ terms, that's pretty normal practice. In precast, not so common. The problem with some of the cement replacements is just getting that balance between the curing time, so and the manufacturing process. But yeah, we looked at that. But equally, if you haven't got to make it, then that's far more carbon neutral. Design life of the structure was 120 years, so we maintained that 120 years design life. Between the cost and the so because we had the luxury of Mark show this, how much trade-off did you have between cost and carbon when optimizing thickness and rebar content? Well, the good thing is the first thing we did was reduce unit thickness, so that gave us effectively, if you like, the budget to have that trade-off. So we never came to a point where we were overly concerned by the fact that we were becoming financially viable, because we were taking weight out of the structure. Have you accommodated for so Rob W, have you accommodated for the embodied carbon associated with that mix, etc.? Yeah, so we mapped through in all our calculations down to the nth degree. So to start, I think when we mapped through our carbon, both in the new solution and the existing, we got down into finer detail. So we were looking at travel distances of the pegs that held the insulation in place and those sort of things. We've got lots more questions coming in.
Yeah, got loads. Thanks for your questions, guys.
Could alkali activated cement material be used instead of OPC? It's a good question, and what I'm not an expert in, to be honest. So look, I think low carbon concrete, I think when we look at things like CEM3 and those sort of, that's where we'll end up. GGBS will have to become redundant at some point. and we will get those golden bullet solutions that truly drive out carbon, because ultimately GGS is a waste from another polluting industry, and so we are seeing those costs soar. I would agree, but I suppose in my mind it's better doing something now than waiting for that golden bullet. Good presentation, thanks. Was it driven by the client or contractor? Neither. It was there was a desire from the client to do something. Equally, they didn't want to distract their main program, and we approached Innovate UK for funding to do the research with the supply chain. So I don't know if you noticed from the start, but we didn't have the contractors involved. They were concentrating on the alliance to get that up and running, and we went away as a standalone project. So I've got those questions coming through. I remember we said perhaps on the effect of controlling temperature and mixing use going. Did you consider? So did you have you read? I read multiple research papers on the effects of controlling temperature of mixing. Is that something you are looking to do? That so the last piece. I think there's a good opportunity there. We started to play around with it. We didn't get any final using sensors to track with real-time weather data. Can definitely have a benefit of reducing cement content. I think that's a really good point. Do you think we should know the CO2 emissions for each concrete mixture rather than just its strength? Absolutely. I think one of the things I liked piece about the project was the BIM models that were created into the heat maps to see where carbon sat. I think I found that as a visual person really useful, and I think you're looking at everything through the lens of carbon rather than time and cost was really insightful, and made me think, well, maybe I should know this information anyway, but yeah, I think we should definitely do that. And bringing forward EPDs is a document that we hold to the fact that they should be accurate, but equally considering their content. Prisons now are easier to tunnel out of due to reduced concrete strength and reduced reinforcement in walls and slabs. So actually we're maintaining the concrete strength, we just reduced the cement, but we've maintained the security level. So whilst I've never tried to tunnel out of a prison, I believe it'd be equally as difficult. You probably just easy to walk out the door. So using admixtures such as GGS it reduces initial strength formation to release from the mold. I think a high percentage such as 6% could reduce carbon. How would be the best way to make? So when we did the trial, and that's the piece we looked at really, is around the optimum of manufacturing and remaining commercially viable, and we got to about 50% before confidence within the process started to wane. I think on a good day, if the weather's good, then 60% is definitely achievable. And admixtures are progressing all the time. So the admixtures in terms of the chemical admixtures are becoming, are moving all the time and improving all the time. So maybe what we knew 10 years ago, 5 years ago even, again, about some of those admixtures, it's just keeping an eye on those, I think, and looking at which ones are. Equally, we found 1 or 2 admixtures that got to a certain point, and when we applied too much of them, the mix became really inconsistent. So trialing and making sure that what looks like a good idea on paper, and we certainly had a few good ideas on paper that when we mixed them up didn't come up with the outcome we expected. So trialing and ensuring that we've got technical readiness, I think is really important. Is the precast demountable or to replace, or just for demonstration purposes, does the integration used of services in the precast mean that these cannot be recycled for aggregate, etc.? So they're not demountable because it's a structural facade solution. So the precast effectively forms that structure and isn't hung, and the external skin isn't hung on the building. It's part of the facade. No, I think the MEP components that are embedded would just be recycled the same as the aggregates and as the reinforcement at that point. My hope is that because they've got such a long design life, that the buildings are repurposed rather than demolished too quickly. And I think if we look at carbon content, the reuse of buildings and the repurpose of buildings is by one of the easiest ways we can reduce our carbon footprint. So could you look at carbon reduction in the formwork? So one of the reasons we use steel molds, really high quality steel molds, is to try and reduce the volume of plywood and timber within the mold. So steel molds include more carbon because they're steel in the first instance, but the usage out of them soon means that you end up with effectively less carbon over the lifetime of that casting process. And again, going back to that platform, the reason you get that amount of reuse out of the molds is because you're making the same component over and over and over again. Whereas if you keep redesigning, you end up with every project having bespoke molds and not getting that reuse. I think I've covered most.
Do you think you've covered? I've basically been in the Q&A. I've been sort of clicking done when we've gone through the ones that we've answered. So I think I've got them all. But if you think you've covered them all, John, then that's great. We just have a quick check. Did you answer the question on the supply of PFA and GGBS?
I've been told there is a reducing supply of PFA and GGBS in the UK. Closes coal-fired power stations. Did you have any problems getting hold of PF and GGBS? I would agree with you. There is as much as the reduced supply, I think there's an increase in demand, a bit like gas, and so we haven't seen any supply chain issues, but there is that risk, I think, as there is in a lot of materials at the minute, and certainly over time, I think there will be, we will need to find a different solution. But I think it's that balance between doing something now and holding off for that, that future.
Okay. Okay. Are there any last questions for John before we close? We've still got a bit more time, so we'll just kind of keep answering questions until they're all done, I guess. Just a lot of great stuff, thanks. So that's good, good to know. Just while people are having a last chance at kind of putting in their questions, just like to direct you to our feedback form. It really helps us make sure our sessions are suitable for the supply chain and clients and everybody who interacts with our materials. If you complete our feedback form, so I've put the link in the chat, and it will only take you 2 minutes or so. So do have a go just filling that in. It'd be really helpful.
There's a last question there around how much influence can you have over the manufacturers of raw materials, the cement, and reducing carbon emissions? So I think if we all keep on saying that's what we want to buy, then that brings pressure. The cement organisations have a net zero plan, which is published, and we should look to hold them to account in achieving that, because ultimately it's cement and the reinforcement that make the biggest difference. So applying pressure, and some people from pretty large organisations on this call through their supply chain departments should be making sure that when that procurement's happening, they're buying from the most carbon neutral sources. there's nothing like losing market share to draw people's focus. So organisations stating that's what they're going to do and then doing it will accelerate change, no doubt. So is the information on recycled content of rebar easily available from various manufacturers? Yes, if you approach your manufacturers and ask for their EPDs, Cares Cares who certify or generally certify you rebar coming in to the UK has been well effort. We've got a sustainability certification as well. So one of the great areas to look at if you want to learn more about sustainable rebar or less polluting rebar, which is sustainable, is the Cares website. They've got some really good material on there, and if someone's certified through them, then you'll find the EPDs from them there.
Do you think we've covered everything now, then, John?
I think so. I think questions are dropping off. So
yeah,
hopefully we can give people 10 minutes their lunchtime back.
Yeah, of course. Great. Well, thanks everyone so much for getting involved. It's obviously a really important topic, and it's great that we had John to share his work with us today. So thanks so much, John. Yeah, I'll just leave you guys to have a bit more lunchtime, and I hope you have a great rest of the day. Do check out our website for any upcoming events. There's always loads going on at the school. So yeah, thanks very much. I'll bring the session to a close.